it's really nice to be here, but I took 24 hours worth of flights yesterday, so bear with me. So I'm talking about data that lives everywhere and nowhere. Whoa. Okay. So I work for Code for Science, and we are a nonprofit. Everything is done open source, and we are funded by rich people who want to give us money. So we're really tasked and interested in the difference between a centralized and a distributed network. We build tools for distributed peer-to-peer networks. So, oh wait, I'm missing the top here. Yeah. Sorry, everybody. That's all right. Just let's go for it. Whoa. Okay. That's okay. So, so one of the big, so we're talking about peer-to-peer. So one of the big problems that we're trying to solve is how when you have a lot of people trying to access the same server, bad things happen. So this is one of the biggest reasons for peer-to-peer that we were first tasked with for scientific data. When you have really big data sets that tons of people want to get access to, it's really hard to have just one server. Another reason people like to use peer-to-peer is for Big Brother. Be careful of the Big Brother. People want to be private and secure. They don't want to share their data with a centralized service, for example, Dropbox or Google. This is from the Catalonian referendum when Spain was censoring websites. This has happened just last month. So people were using peer-to-peer to get around also these censorship blocks on different websites that governments can often do. So peer-to-peer is used, for example, BitTorrent to get around that kind of thing. People have also been using peer-to-peer to help people in the Amazon. This is people in Ecuador and Guyana who are mapping their communities using peer-to-peer technologies. This is a application called Map.io, which I've been working on, which allows people to map offline and share their OpenStreetMap data without connecting to any central server. This means they can create maps that are secure and private and work anywhere, even offline. So people have historically been using this kind of technology with like BitTorrent, which is decentralized and it's massively adopted, but it only works for static files. So it's not really that great with really big data sets that change a lot. And it's not secure, so links can be sniffed by third parties, which means that if you're sharing your favorite movie, maybe someone's going to find out and you're going to have your internet throttled, or you get a nice little email that says you owe them money. But we've been working on something that's a big improvement on BitTorrent that's decentralized, and it's easy to use. And it's designed for data sharing instead of piracy, like BitTorrent was. So it's built for modern use cases. It's really fast, and links are hidden from third parties, so it's security first. There have been lots of apps built using DAT. So I built a data registry. It's kind of like a GitHub for data. Beaker Browser is a web browser. That's a peer-to-peer web browser. Someone built an analytics server, which is like a Google Analytics, but peer-to-peer. Mapio was the OpenStreetMap editor I was talking about. Rotanode is a social network that has been built on this, and there's also a peer-to-peer science reader, like a journal. But the most basic way to interact with it is to share, use a command line. So you can type .share, and you get this cryptographically secure link. So this is a .:// link, and that's on purpose, right? We're trying to get rid of HTTP. And it never changes, even if files change. So the great part about this is you can update the data over time, and versions are kept. And I'll show you a little demo about this later. So you give this link to someone else, and they can type .clone, and the data goes directly from their computer to your computer. So let's see how this works. So basically I have two what we call feeds. I have one feed, this is the blue feed, that's my public, and the red one is my private. This is just a key, actually. So what happens is when I want to share my data with the, say, 3 other people, I give them my public key, and then as soon as I give them my public key, they connect to me and I give them the data. So everyone has the data. But then when I go offline, if a new peer comes on, they can get that data if they have the key. If I want to put in new data, then the person with the original private key, the red key, which I don't share with anyone, comes back online, and then I can add more data to it. I'm actually signing the new data that I'm adding, and signing it with my private key, and then so everyone in the network can verify that it's the same person who's adding more data. So then you can see how the data changes over time. I'm going to show you a little demo. There's a dog. Hi, this is my dog. It's not really my dog, actually. I just found it online. I made a website here where you can share. Let me see, I need to mirror these. Sorry, guys. This is. Okay. So this is a peer-to-peer website built with Beaker. I can add comments to the website. So down here I've added a couple comments. Here's another one. Okay, so what's actually going on when I'm adding a comment? So there's a comment right there. What I'm doing is I'm saving it as a file on the file system. So basically you have a new DAT archive here that I've created. And I have a file called comments.json. And then when I hit the button, I add the comment to the list, and then I just write that file back into the archive. And then this archive gets reshared on the network. So what someone can do is I can take this link, and I can give this link to someone else, and they can put it in their Beaker browser. So I'm going to open a new browser here, and they can get access to it. So basically what's happening is that between these two websites, these browsers are actually talking directly to each other, and there's no central authority that the website is going through. Someone can even fork the website, so I can hit fork this site here. So I want to make a website about cats instead. So then I can go into my sites and just switch this around. And then if I go to the cat website, let me see here, cat website, then I have cats. Okay, that's my cat. I see I still have the comments from the dog website, right? Because what I actually did was I copied all of the files from this dog website, then changed a couple things about it, and then it became mine. And then it has also a different link here. So if you look, this link is F2 something something, and then this link is 30 something something. So these are different, completely different DATs that are sharing on the distributed network. So you can make your own website today. There's lots of different ways that you can make websites, though. And so today I want to go over a little bit about all the different ways you can make applications on DAT, not just through Beaker, but through Node. So we have a lot of different ways that you can interact with DAT. So the most popular is DAT Node and Beaker, and those are like the highest level APIs. I just showed you a little bit of the Beaker API. And then below that, we have HyperDrive and HyperDB. And HyperDrive is a way to interact with the file system, and HyperDB is a way to interact with databases. HyperDB is a little bit more experimental, but we'll still talk about it. And then HyperCore is the underlying piece that everything else is built on top of, and it's a simple append-only log. So first, let's talk about DAT Node. So DAT Node gives you simple defaults for importing files. So for example, I create a DAT, and I just give it the folder I want, and then after I give it the folder, it gives me a DAT object, which I can import files from that folder, and I can join the network. So this is a pretty simple way to start sharing files. And then if I give the DAT key to someone else, they can pick where they want to download the files to and what the link is. And then after they get that set up, then it'll create the folder and prepare for joining the network. And then once both of these are joining the network, they'll be able to talk to each other. So this is like the most highest level, simplest way to build a DAT app. So we did the Beaker API. So this is a little bit more lower level, but we have, even lower level, we have HyperDrive. So this is what DAT is built on. So HyperDrive is built by Matthias Boos. And basically, you first create an archive, and you give it the folder you want. Then you can write a file to it. So you just say, this is the file I want, and this is the stuff in it. Then you can actually, it has an FS API, so it's exactly the same as the FS API. So I can read the dir that I've been writing to, and then I can get the list of files out. And then I can also read a particular file and get that data. So this is a really simple way of interacting with file systems. That's all peer-to-peer. So then if I want to send it to someone else, so this is where someone else is actually going to get the data. There's actually many ways you can do that. The most simplest way is to simply replicate the archive, create another one, which is this clone on line 2 here. That has the key and the folder, and then you just pipe them together. So this can happen over anything. It can happen over WebSocket, it can happen over HTTP, it can happen over WebRTC, if you're familiar with that. So one of the modules that I built is called HyperDiscovery, and this just takes an archive and does all of that for you. So it actually connects to peers using DHT, DNS, or over LAN. So we're actually connecting everybody over this network. And this is what we call like the DAT network. And there's lots of different ways to do this, but we have 3 main ways that we have built in. So I want to talk about how do they find each other? How do these 2 peers actually find each other? Because it's a little bit complicated. So like I was saying before, the key is secret. It's private. So if you want to share your data with someone, you don't want other people to know what your data is necessarily. So what we do is we create a hash of this key, which we call the discovery key. And this key is broadcasted over the network, not the original key. So basically the only peers with the original link can compute the discovery key. This means that over the network, if you're going to see all the people that are sharing, if you're able to see all the people that are sharing all the keys, you're only seeing the hashes of the keys. And you're only able to compute the hash of the key if you have the original key, and the say if I request from you, hey, I want this key, and because I'm sniffing you, you're going to ask me for the original key. And so unless I have the original one, we're not going to be able to talk to each other, and it will fail for security reasons. So this is something that BitTorrent and a lot of other peer-to-peer apps could do very easily, but they're not prioritizing security, and this is something that we've been prioritizing. We really want you to get your app back. Give me my app back. That's what I want. So privacy and security first. So if you're able to make a connection, you can see how many peers are currently connected to you by doing like a connections.length on the swarm object. So all of this is built over HyperCore. And HyperCore is just logs over peer-to-peer, which is pretty amazing that you could model different kinds of data structures over a simple log structure. So if you wanted to, you can interact with HyperCore, which is, it's just a file, a series of files, and this feed is modeled as a log. So I can append the word hello, and then I append world, and then if I get out 0 and 1, it's going to give me hello and world back at me. And this is very simple. It's actually something that I'm really excited to show you the next phase of things, which is called HyperDB. But let me show you a little bit. Let me show you a little bit of HyperDB. Actually, I think this is so. So what I was saying before is that you can only add. There's only one person who can add data to the feed in HyperCore, and this is and in DAT. So if you have a private key, only the person with the private key can add, right? So what we wanted to do in the next version of DAT is have multiple writers. So like I was showing you before, when someone has the key, they can only share it. The only person with a private key can update the data. So we've introduced HyperDB, which will be the next underlying piece of DAT. And HyperDB is just as simple, but instead of appending, you're actually putting. And you can, so you put like a path, and then you can get out that path later and get the value out. So it's very simple and very similar to HyperCore, but you can also add owners, readers, and writers, and so other people can write. So I want to show you a little bit of a demo of some of the work that has been done. I'll show you a little bit of the CLI tool. So I have this this link here that I'm creating, and as I'm cloning it, as I'm sharing it, I'm also downloading it, and I don't have to wait for one side to finish before the other side starts. So let me show you that again a little bit here. Excuse me, sorry. It's awful. Okay. So as this site is loading, it's like I'm able to download from the other side. And yeah, I started just almost full. And so this is scanning really fast. If you notice, it's like hard for me to even like demo this because it's going through almost 2 gigabytes of data so quickly. People have started to replace some stuff like our rsync and SCP with this tool, which is pretty great. We've been trying to prioritize efficiency as well as security. So if I wanted to edit some data, so I could share this. So say I'm sharing this text here. It says, "Hi, hello. So if I wanted to say hello, hi world, and I could share this over here. Cloud this over here. What I can actually do is do a, let me see, you guys can't see that, can do a .share HTTP. I think that's, yeah, so now the files are also served over HTTP, so I can look at this. I can just go to localhost 8080, and I can give this a domain name and everything. And get access to the files. So this is like version 3, but if I look at world, I should say hi world, but if I go to version 2, I'm going to see version 1. Oh yeah, so I don't see the file at all. So, so as the versions change, you can see the changes in yeah. So you can see the history of the data over time, which is really important for a use case of basically replacing Git and SCP for a lot of people. It's really important for people to go back in time and be able to see the history of their data. And it also gives you a really awesome feature when you're doing something like a website, because you can see the history of the website. So this is, for example, something that Tara Van Seal made, which is a sort of like a paste bin for DAT. So I can create a little note. Node conf loves cats. And I can create this, and this is my site, basically. So what it does is it forks that original site and creates a DAT, which has my information in it. But someone else can fork the site or update it over time, and I can see the history of the website. This is good in some cases, and in other cases, you might want to have the site completely disappear. The great thing and the bad thing about peer-to-peer is that as long as, if I give this link to anyone, then anyone can get it. So in a case of censorship or something, if I give this link to people and share this link out, then more people have it, and it's really, really difficult to censor something that I can pass from one person to another. But in another case, if I'm trying to keep data private, if other people get access to this link, then there's no way for me to revoke this link later on. As long as someone has this link and has the original data and the log and the history of it, then anyone can share that link again. They can't modify any of the data, but they can share it over and over again. So it's kind of a double-edged sword here. I wanted to show another cool demo, which is a live stream demo. So this is using FFmpeg. So basically, I do this bit.sh, and it's recording my screen as I'm speaking, and it's creating these TS files. So I don't know if you've ever seen these TS files, but it's going to create a bunch of them as my screen is recorded. And so since DAT works on file system, all I'm doing is sharing all these TS files. And as they're added, so see down here, it's adding another file and going on over time. Then I can go to the browser and copy this link. This is the Beaker browser. And see the live stream as it's going on. So this is awesome because as more people, so see I have one peer here, as more people come onto the network and look at this link, then the more people, the faster it'll be, and the more people can get access to it. So if I'm live streaming from my computer and I give it to all of you, some of you might start getting the files from each other rather than getting all of you getting the data from just from my computer. So that saves a lot of bandwidth. So some frequently asked questions. There weren't any, there's no question time, so I was like, well, I might as well do some frequently asked questions. So using domain names, people often ask, hey, that link that you're sharing around is super long and annoying. Can I just use like a domain name that I would normally use? MyCatsAreAwesome.com. And you can. You actually, all you have to do is put .wellknown/.dat. You put the link that you want to share, and this is the time that until it'll be refreshed. And so that's a time like 3,600 milliseconds till it'll be refreshed, and the person has to go back and look it up again. So people are using this right now to share DATs. So you can, and it's the Beaker browser as well, the CLI tool, and the DAT node all speak this. So what if I don't want to download all the data? So this is a really good use case for example in the science journal. So there's a science journal called Science Fair that is a desktop app that I can show you. Just Fair app. This is the Science Fair app. So people can, it's a desktop app where people can share and access scientific articles directly from each other instead of from a centralized service. So this is amazing, but what if I don't want to download a terabyte of scientific articles in order to read one of them, right? So that we have a sparse mode that you can use. So when you create your HyperDrive, or if you create your DAT using DAT node, you just pass this sparse true option, and it'll first download just the metadata instead of all of the files, which, unlike Git, DAT has really small amounts of metadata, so the content is not stored with the metadata. So this means that when you download the metadata only, it'll be like 1/1,000,000th of the size of the content. So can I go back in time like Git? You can. So you can do an archive.checkout, and you can give it the version number, and then you can just download the file that you want to get. Multiple writers, we talked about that, HyperDB. So what about on-disk security? So, okay, so in transit, it's secure. We're doing all this cool stuff about in transit. But what if, like, someone comes to my machine and corrupts the data, and then other people come, and try and get the data from me, but it's not the data that I had. Someone hacking me. So we use a Merkle tree, which is the same thing that Git uses under the hood, and also IPFS. It makes it so that as people are downloading from you, they're checking the hashes of all of the data that's come before in the log, which means that you can verify that all of the data that you're getting is correct. So even if someone manipulates your bits later, it'll be okay. And you can read more about this in our white paper, which you can get on datproject.org. And there's tons of community-built apps using DAT, so please take a look. And I would love to see if anyone wants to make more apps or have some cool ideas. I would love to see like a Facebook group or an event calendar kind of replacement. That's peer-to-peer, so just get in touch with me, and happy to talk. Thanks a lot.